All right, welcome back to, I'm just going to say post-pandemic, even though it's not true, number 2 API Meetup. So I see a number of familiar faces from last time, the dedicated few. Anyone here for first time? Okay, all right, we got one. We'll make her feel welcome. Was anyone's last time the first time? Okay, cool, so that's good. Yeah, it's been a while, so if you're here and haven't spent time with humans very much, it's okay. We're all getting used to it again. It's going to be awkward for a little while. Embrace it, be awkward. You're with like-minded awkward people. It's okay. So couple of logistical things for those who haven't been here or had too much fun with the alcohol last time. The bathrooms are up by the elevators, just to the right before you get to the elevators. If you enjoy hot yet breezy weather with nice, wonderful views, we will be able to head up to the rooftop after. But we will kick you out at some point. Lexi, what time do you want to be done? Okay, so at 8 o'clock, one of us will be a bouncer and ask you to leave. So don't overstay your welcome, which is also to say thank you so much to Lexi and the Ship Engine team for being, having done lots of these things before, the most generous, accommodating hosts we've ever had. We show up and do nothing, they do everything. So thank you, Lexi. We will continue to try to do the monthly cadence. I imagine we'll probably end up doing the skip the holiday months kind of thing like we've done before. Probably do the 10 a year sort of thing. So next one will be July 21st. Speakers yet to be determined. Feel free to reach out if you know someone who has interesting things to say. What did I forget, Lexi? Thank you. See, I knew I'd forget something. There's a bowl full of parking validation tickets up by the front. Don't forget to take one or it costs you $50 to get out of the parking garage. So there is a penalty for forgetting. Otherwise, definitely don't be a stranger and bounce out at the end. Like I said, we'll hang out here, hang out on the roof. There's drinks, there's food. So, you know, be welcome till 8 and then get out. All right, and with that, we were fortunate this month in that by weird chance, the APIMatic team was traveling through Austin in the same week that we were planning to do the meetup. So we opportunistically grabbed them. They're traveling here all the way from Pakistan. So if they look tired, be gracious. They're on tour here. So I want to welcome Mehdi, their Chief Product Architect, to share with you guys a little bit about SDKs, which if you've done APIs for a while, you'll know is an inevitable thing.
Does it work? Yeah, good. There is a huge pillar here. Hey, so I'm Mehdi, and I'm going to be talking about API onboarding. And I'm especially going to focus on the SDKs bit today. So let me introduce myself. I'm the Chief Product Architect at APIMatic. That's kind of a product and engineering role combined into one. I started at APIMatic leading the team for code generator. So APIMatic generates SDKs, client libraries, and we also generate API documentation for folks who are creating their own REST API. I also led the team that created the API portal, but SDKs is where we shine, right? And while I'm not working, I also work as an evangelist for developer experience for API. So just a quick intro to what APIMatic is. Okay, so APIMatic generates SDKs and we also generate API documentation. We try to focus on the whole developer experience of using an API. So if you're someone who's just releasing an API, you would want that your API users have the best possible experience. So there is a lot of things that you need to put out when you're releasing your API, and we try to automate as much of it as we can. We do that by having a code generator that can create line libraries, but of course, to use that, you also need to have an open API file. So that's where we have editors and other tooling like Stoplight, and we have README that create documentation and provide an editing experience for API as well. So a quick outline of my talk. Basically, I want to show you guys how I'll take a look at the API onboarding journey and what I think is the big missing artifact that an API onboarding journey should have. Also, I'm going to talk about the big hint is that I'm going to talk about SDK, and but mainly about what SDKs can do for API integrations and the big 5 things that every SDK should be doing and what exactly you need to do in your code to achieve that. So that means I'm going to end up showing how to make great SDKs. Okay. So let's start with the API onboarding journey. So if someone is trying to use your API and they want to build an app using your API, there are 3 distinct phases that they go through. The first phase is that you're basically discovering what your API is about. That is where your marketing pages or where your product pages help get the user started with that. And then you have an explore phase where they're just figuring out what use cases your API supports and how my business can basically use that use case and fit your API into my app. And then the last phase is integration. That's where the real magic happens. That's where someone is using your API to build an app, and that requires writing real code. So to achieve all of this, to help the API consumer use your API in their app, basically you have to provide a bunch of API onboarding artifacts. So like you might have an API marketplace, you might be listed on an API marketplace, or you might have a search place where people can find your API. Especially if you have multiple API, it makes sense to have a page where you have everything listed in one place. And you might be creating API reference documentation, you might be creating a console or something where they can basically explore all the APIs. And then you have code samples that are inside these API reference documentation. That is where I'm going to focus on today, because if someone is just starting using your API, they want to write code and basically they're going to be copying your code samples into their application. And a whole bunch of things go wrong when they're copying your code samples. Integration doesn't work until they write their code. And to write code, they need code samples from your side. Why do they need code samples? Because that is basically the fastest way to get started with an API. Either you're giving them an API reference and they recreate all of that call code by hand, or they're copying your code samples into their application code. I want to take a look at a code sample and that I just picked from a random API portal and show what exactly I think goes wrong during API onboarding if you're not taking care of everything properly. So this is just a random site, so don't take it out on that. Did a pretty good job with their API portal, and they do have all the things covered. But this is an early code sample that I saw on their website. So usually code samples are being put together and they do not really take care of whether this stuff is going to end up in a production application. They made several mistakes here. You can see that they're kind of telling the user that, hey, it's okay to get started with just initializing an OK HTTP client. This is a Java code base, but the principles apply to all bad code sample. And they kind of make another mistake where they have all this REST related information nested right inside the code sample. The key bit is that it doesn't really matter how the API call is being made. It matters what the product is actually doing. But they have all this redundant information inside their code sample, which is just a distraction when someone is getting started with your API. And then the funny thing is that they're kind of telling users to embed the API key inside the code, which is quite bad from a security perspective. And then they have all this weird little JSON code that I don't think people are going to like, because they don't write code like this. They're usually gonna create classes, they're gonna set up their serializer. There's a lot of plumbing that needs to happen before this code sample ends up in a production application. So sorry, not this slide. Yeah. So this code sample, if you try to rework it, you will find that you have to remove the bit on the top. You have to basically share the client between all areas where you're calling code from. You're going to have to rework all of that JSON bit and make your own classes. You're going to find that all of that bit where they have the URL embedded in the code, this is going to be shared among all places where you're calling code. So this have to be refactored heavily before someone starts using your API. And when you keep refactoring it, you're gonna end up somewhere where the API onboarding experience should have started from, that is SDKs. You're gonna end up refactoring all of this code and probably multiple code samples that you have copied from that site, and you're gonna rework that into reusable client libraries, which we call SDKs. So if an API onboarding experience started with SDKs, they wouldn't have to go through the whole problem of thinking about how I'm going to refactor this code. What are these routes doing? They're just getting in the way of using the product. So if you're thinking SDKs, really, do people really start their API onboarding experience with SDKs? So I want to show you some examples. For example, Stripe has a pretty good API. You guys would agree with me on that. So, and they kind of ask you to select an SDK right on top of their page, because they know that the API onboarding experience is all about getting the user started with their integration as fast as possible. So that would only happen if they give you something that you can take into your application code today. And it is gonna actually get the user started as quickly as possible. And you see the same pattern happening in other API portals as well. So you have all these nice APIs that I like, and they all get the user started by first having to select a language for which they're writing code. So best SDKs, best API docs are SDK first. That means that if you're creating an API reference, you should try to work your content in such a way that you're talking about how to use this API in your code rather than telling how this API works. Because all of that little nitty-gritty details about whether this is a post request or whether the keys are going to go in the header are just implementation detail of the API. And writing production-ready REST API integration is already so hard. So if the developers are spending hundreds of hours working on your API into their application, I think we should make the best use of their time. So what can SDKs do for API integration? I want to tackle this question in a way that we end up with a discussion where we see what things should go inside the SDK. So what can SDKs do for API integration? Well, to start with, they make API integrations accessible. They make API integrations approachable, maintainable, robust, and reliable. What exactly does this mean in terms of code? It means that code that is easy to understand, code that is easy to get started with, code that keeps working over time. And then you have code that works in all cases and code that works when nothing works. So let's just quickly dive into each of these qualities about SDK to see if you're building an SDK by hand or if you're evaluating a code generator, what should you look inside that SDK that you can tell that, hey, this is a good SDK that I should be using. So how to make great SDK? To start with, let's talk about accessibility. That is, how can SDKs make application code easier to understand? So if you take any product, basically there's the whole domain where I'm taking an API for payment as an example. But if you see the product is actually about payment, billing, receipts, and there's a lot of things that your team basically put an effort into making. And then there's the whole REST API layer that helps expose this product. And the REST API layer is actually talking in a whole different language on its own. So if anyone is actually writing application code, they're integrating your product into their application, they have to go through a translation layer where they're translating everything that they have to do. Maybe it's making a new payment request. Maybe it's getting all the billing details for a user. They have to translate each and everything that they're doing into the REST API language layer. So they have to figure out whether this is a post request, so or how the request body should be sent. Although that is not really the main goal of their writing a code, what they just want to do is use your product. And the REST API layer, it's fantastic that you work on a great API design. The thing is that it is just a layer that they have to pass through to get their job done for today. So there is a wide chasm between the product and the user app. And we need to do something to patch this gap between the two things. So I believe that the API delivers the product, but the SDK is the right interface for using the product. If the user is thinking about APIs while they're using their product, it's good, but SDK, thinking about SDKs would be actually faster, because SDKs kind of give them the same language that they're working when they're which they are working in. For example, if I'm writing PHP code, I just want to know how to make a payment. I don't want to know the details about how to make the request for that payment. That can be all wrapped up and hidden away by the SDK. So if you want to make your API accessible, you should work on a REST-agnostic interface, which is what the SDKs are for. So all these neat little methods in your SDK kind of help the user stop thinking about the API details, which of course they exist, but they are implementation detail. So, and once you have your SDK, which with all these features, you should also take care of a few things that even though someone is using your SDK, you should always have escape hatches, because escape hatches. So because if they're using their SDK, they will eventually run into corner cases that your SDK does not support. So this is a diagram of a middleware, but my point is that if you're making an SDK, you should always have a escape hatch where they can always make their own API call if they need to. So the next big thing that an SDK needs to be able to do is make API integrations approachable. That means you need to make sure that an API integration is something that someone can get easily started with. So how do we do that? So it's not just that SDKs have code, you have to package them in a way that someone can just get started with them in 1, 2, 3. So for example, make sure that your SDKs are properly published as packages, because then it means that it's only a one-line command away from getting the SDK in your code to the next step, which is about setting up the SDK. So I also asked SDK designers to make sure that your SDK is as easy to initialize as possible. So for example, if all it takes to call your API is an access token, so that is what the SDK initialization should look like. There shouldn't be any extra steps between doing this and getting started with using the SDK. You can even go ahead and simplify this even further, because if the best practices say that, hey, load the access token from the environment, so just create a method for that. And make sure that once you have your SDK ready, you have code samples that are ready to copy. Because if you don't have that ready to copy, people will be basically copying all these spaghetti code and reworking them. But what you want to do is end up somewhere here where the SDK has an explicit initialization phase. They have a phase where they're preparing the request, and they have a phase where they're making the request to the API call. And all of this is neatly wrapped up, so they do not even have to understand what headers are going to the API call. They do not have to figure out how an object is serialized. All of that should be wrapped away. And the API call should be a pretty simple, easy to read code. And once that's done, what you have done is that you have ended up in a situation where your SDK is approachable. You get the users to hello world in 1, 2, 3 steps. Another an extra tip from my side is that what really makes API portals click is that not only you provide SDKs and code samples, but you also provide complete applications that someone can just clone, copy, and just play around with. This is pretty helpful because if someone wants to see what the whole API integration is going to look like, they don't have to work through your whole tutorial or getting started guide. They can just view it on GitHub and see that, hey, these are the 4 or 5 endpoints I'm supposed to call, and this is what my code will end up looking like without actually putting in any effort. Another big part of SDK, where SDKs help with is maintainability. And it's kind of a challenge that comes up a lot at APIMatic as well. So if we are creating SDK, we really focus on making sure that we provide types for all the schemas that an API exposes. And that's really important because if you're not writing schema, then someone has to write the schemas for all the, write the code for all the schemas your API has. This is just an example code, example of what a large API's schema list would look like. And it's not even at alphabet D. You have still all the way, you have to go all the way to Z before this list ends. So if you're not writing this code, then someone else will be, and they will basically be doing the work that an API provider could have done for them. And having this first party support for types in the SDK means that there is only one source of truth about what a person or a payment model would look like. Whenever you get a request support ticket, and it's not going to be a discussion about how you are interpreting this JSON schema versus how I am looking at it. It's going to be exactly the PHP code that you guys are going to be talking about. And that's very specific, and it's a single source of truth that can go wrong. Another challenge when someone is using SDKs where you can help is that language churn is a real problem. So if they're using PHP or Ruby, they also are kind of writing code in a language that changes over time. And you have to change your SDK with them, with that language change. I want to expand this diagram a bit because it shows how many language versions churn throughout the years. This graph is only for 4 years, and you can see that language churn is a real problem. You can see that TypeScript, TypeScript released 4 or 5 new versions in 1 year between 2021 and 2022. And that's not the only problem. You also have to track that certain language versions are gonna deprecate over time. So that great Java 11 SDK that you made in 2020 might have to be deprecated 2 years later. So good work on the design, but it is going to be replaced with a new version. So keeping up with this means that you have to make sure that your SDKs target the widest number of versions that the community is using right now. And you have to make sure that the people who are using your SDKs are able to update without too many changes in their code. Because if you are releasing a breaking change every time there is a language version update, people are just gonna stick with the old version, and that's not good. And that's actually a problem because sometimes languages themselves have breaking changes. So some languages help you tackle that in a good way, but otherwise, sometimes you end up making 2 versions of SDKs, and that's one too many, right? So help users fight code decay, because if you are not doing that, again, they have to do it at their end. And that's just another roadblock in them using your API. And this goes without saying that if your SDKs has dependencies, it means that you will have to tackle bug fixes, you have enhancements that are coming in their dependency, and then you have security fixes. This is just a small list of security issues that our TypeScript SDK had when we started development, and we were just 3 months into development. So we started with 0 vulnerabilities, and it was like, whoa, this list is big, and we are not even done with the SDK. So this means that the ecosystem churn is kind of creating all these security fixes that you have to keep up with as well. And all of these fixes then have to be propagated into customers' code base where where your SDK is used. So, but to tackle some of this work, what you can do is that you can set up automatic update bots. It gets you half the way, but it creates a lot of noise. GitHub has a free depender bot, and then you can also kind of track language releases. The way that my team does is that they test their code against multiple language versions, and they also make sure that in their test, they're targeting the latest version of the language as well. So let's say if PHP releases PHP 9 tomorrow, and we have a CI run, we would automatically know that our SDK is actually not working with PHP 9. So having that latest tag in your CI pipeline is pretty important to keep up with the latest language versions. So just to summarize, for maintainability, make sure that you're providing the complete code. That includes all the type code as well. Make sure that you're tracking language updates, and then make sure that your dependencies are up to date. And sorry, another thing to mention is that dependencies have to also sometimes change when language version changes. So that's yet another headache that people have to deal with who are writing SDKs. This is the fourth one. So what SDKs can help with during API integration is robustness. That means helping code work in all cases. The way that we do that with SDKs, that you provide compile time checks with the help of models. So if someone is writing a request code, they should quickly be able to see that, hey, am I writing the right type for this data that I want to send? So if you're writing code in Java or C#, that should be easy to do. But if you're writing code in a language which is untyped, what you can do is provide runtime checks as well. So this is an example from our TypeScript SDK where someone was complaining, hey, I'm sending the ID. And we were like, no, you are not sending the ID because our runtime checks actually catch that issue that you're making the wrong request. So having that confidence in the request that you make is pretty important. And that also saves a lot of time on their customer support end as well. And I like to stick with the law that if you're writing network related code, you should make sure that you're conservative in what you send. So make sure that your requests are right, but be prepared to handle responses that are wrong. So your SDK should be written with that perspective. So if you have written robust code, you might be also wondering, so I did write robust code in Java, C# and other type languages. So what can I do about the languages that are not typed yet? There are a few type checkers available. For example, with Ruby, you can use sorbet, which provides you something like this. You can get ID type hinting, and you can also get runtime checks with that. So making sure that your SDK is typed using these type checkers, and they're statically checked, and they have the runtime checking available, kind of helps catching all the issues that are gonna come up later anyway when your customers are using SDKs. Robustness, a summary, make sure compile time checks are there, runtime checks are there, and error. And the last thing that your SDKs help with is reliability. That means since you are writing code that works in a network system, make sure that you are handling the effects of the distributed system as well. Network can go bad anytime. You do not know whether the server is gonna be there, because either they can go down or your link can get cut off. So how do you protect against that? You make sure that your SDKs are able to recover from errors, and then they're able to retry requests that can be retried. Sometimes requests cannot be retried, but hey, let's try anyway for requests that can be retried. And you want to make sure that in case of a overload at the API server, you are handling API throttling as well. And if you can do it, then circuit breaker is also a very nice option that helps prevent overloading an API server just when it's trying to get back up. If you're writing an SDK by hand, then you will find packages where all of this is handled for you. So you just need to connect it with your HTTP client and it will work. But sometimes you need to have API server support as well. So API throttling cannot work if the API server also supports it. And make sure that it's pretty easy to get started with this in your SDK. To summarize, reliability means having timeouts, retries, throttling, and circuit breaker in your design. And then just to summarize everything that I talked about, if you want to make API integrations approachable, accessible, maintainable, and robust and reliable, you have to basically implement this matrix in your SDK. So either you implement this matrix in your interface, or whatever you miss here, your API user will end up doing by their own, which is which means that they just have to do the extra work. So on with SDKs, you have a pretty happy user at the end of their integration journey, hopefully. And yay. To summarize, if you are looking at your APIs release, focus on the API onboarding journey and try to make the docs SDK first. But to do that, you will have to write SDKs or generate them. And if you're writing SDKs, I hope that my matrix that is about what the SDK should have helps you in doing that. So once you have good SDKs, you have happy users, and the end. So do you guys have any questions?
So often when I'm writing tests for our application, if I'm writing tests that are functional or integration tests, a lot of times I find I have to write fixtures for our API SDKs that we use so that they'll return like sample data like I can find in the documentation. But I haven't yet found an SDK that actually provides that.
Yeah.
Is that like a real need, or is that just indicating that I'm doing bad test design?
Yeah, so I think a lot of SDK providers, whether they're writing by hand and even people who are generating SDKs, they kind of focus on getting the SDK design good and making sure that it works. But if that's where the story doesn't end, right? Someone is going to be using this SDK inside their framework. Maybe they're using it in Spring, or maybe they have a Laravel app. And that you have to kind of consider that your SDK is going to be injected. They're using their DI, and you are going to be writing tests where this SDK might be a part of the flow. And I believe designing the SDK to have those interfaces, which can later be replaced by the API user, is a critical part of SDK. I missed that, but thanks for bringing that up. But so getting that right is important. I didn't touch testing, but getting that right is important. And there's another thing that SDK providers can do is that having an ability to log all the requests and responses and let the API, the person who is writing the test, replay that is also kind of helpful, because if you're writing a test, either you are providing a replacement for the real SDK, which to make sure that it doesn't send the actual API call out, or the SDK provider can do that for you. They provide a pre-recorded set of responses against which you can write tests, so that you test your application layer, but whatever interactions it has with the SDK, they don't actually hit the network. You just get a predefined set of responses from it. So yes, it is missing in a lot of SDKs, and it's something that we are kind of struggling with, but we will get it right eventually. Yeah.
So that sounds like just a ton of work. Like SDKs are they require a lot of care and feeding. And if you ask like the salespeople, they want SDKs for all of the languages. Do you have any like tips or things to think about when you think about undertaking building out an SDK, and like when is it, like how much do you have to like really devote to it, and like is it worth it, and things like that? Is it just really a judgment call, or anything, any thoughts on that?
Sorry, can you repeat the last sentence?
Really just like when do you decide that you are going to create an SDK for a new language? When are you going to bring on a new language? Like, is there a tipping point? Is there any sort of thoughts or feelings that you can share about that?
Is there a tipping point where you should start making SDKs? Did I get that right? Okay.
Yeah, for a given language. Like,
Oh.
if like, you know, you always like it's very clear oftentimes that like, oh yeah, we can support Node.js, but then you have this, you know, salesperson who's like, but I can't sell to these people unless I have one for Java and PHP and Ruby and, you know, on down the list.
So I think it's going to be different for every API provider. It depends a lot on API as well. So why is that? So if you take a payment API, for example, they're going to end up in being used in maybe e-commerce stores, and those e-commerce stores are already providing integration for those API. So if you're, let's say, if you're in the e-commerce ecosystem, you will see a lot of PHP startups and PHP application where payments are happening. So certain industries are geared towards certain language. It happens. So you can kind of pick and choose your language there. And then sometimes even your company is kind of invested in a language ecosystem. So you can push that as well because you have connections at meetups and you're talking about, let's say you're going to Ruby meetups. So maybe you can leverage that to market your API during its release. So that's also a good way to go about it. And then you have, again, taking the first example, certain APIs are designed to be used in a way that, let's say you have Azure's API, they're designed to be used in infrastructure deployment code base usually. Either you're calling it from your backend or you're calling it from a CI system where you're kind of asking Azure to deploy your app for you. So these are very specific environments that you can target. You are not going to find that you have to make a web SDK for Azure because it's going to be called definitely from a backend, or it's going to be called from a CLI, which perhaps you can control, and that reduces the number of languages that you target. So it depends on your API really. But if you have an API that is way too general purpose, then I guess you just listen to your customers and figure out what languages they're using.
Thank you.
I answered like a guy with architect in his title. Depends. I love it.
So my question is maybe from a different perspective. How important is it to think about how you maybe reduce liability for your SDK? So for example, you know, if you've given code examples and, you know, this is the way you are recommended to implement, and they incorporate that into their application and it causes an issue, or let's say it breaks at some point, you know, what's the likelihood that you're going to have somebody come back and say, hey, this is on you, not on me, because I used your code? Is that something to think about? Is that a thing?
That's pretty critical, right? So if like I said, if SDK is the interface to your product, then that interface has to work. Otherwise, your product does not work. From my perspective as an API user, if your SDK is broken, then I would say that your product is also broken. So the golden rule, I would say, is that if you're making SDKs and code samples, don't make them if you can't maintain them. So if you're just starting out, figure out how it's going to be maintained as well, and don't release them until you have figured that out. Because if you have an issue from your customer and they're critical to your bottom line, top line, whatever, so you need to be able to have a run book that works perfectly every time you receive that issue. That means you need to have control over being able to make SDK fixes and code sample fixes. And you would only be able to do that if you have figured out how to maintain them properly. So that's where code generators help a lot. If you have a large enough team, you can maintain SDKs as well. This becomes challenging as your API becomes large. So I see people gravitating more towards generating this stuff, but you need to have good control over it so that in case there's a liability problem, that something is broken, you need to fix it soon. Yeah.
Thank you.
Hey, what do you think about data intensive applications where they have a bunch of fields that are queryable? Let's say instead of like you can have maybe one attribute, 10 attributes, 20 attributes. How do you build a flexible SDK in those type of situations?
Can you give me an example of a data intensive application?
So I guess I'm thinking about more like GraphQL type of interfaces where you okay there? Yeah, so I'm thinking about GraphQL where you can kind of specify what you want back from the client. Like you can be like, I want, customers, and the customers have products and orders and stuff like that.
Oh, so are we talking about APIs that have a huge domain, or is it APIs that take a huge amount of data in?
Could you repeat that a little bit louder?
Sorry?
Could you repeat that?
So are we talking about APIs that have a challenge with the large domain that they have? Maybe taking an example of Stripe, who have multiple products and a huge API, or are you talking about APIs where you're passing gigabits of information in and out? Is that your data intensive application?
Yes, the latter there.
The latter there. I would say that if you're creating SDKs for such an API, you will have to probably write it by hand, because you will have to tackle a lot of different issues, and they're going to be very API specific. So if you take an